Next, we have act it out. Acting out the problem is a strategy in which students physically act out what is taking place in a word problem. When given a written word problem in math, students can discuss the critical elements and which aspects are relevant or irrelevant.
Word problems that are tricky to solve are often easier to figure out if you use problem-solving strategies. In the first video, we saw how important it is to pay attention to clue or key words in order to figure out which operations to use. If you have not yet watched that video, go back and see it now. Another strategy you can use, in addition to what you learned in the first video, is to act out or model the word problems using real objects. Sometimes you can use the objects described in the word problem, but when you don't have those handy, you can use other objects to represent them. Let's look at some examples to better understand what I mean. Here is a word problem. There are 10 coins in Linda's wallet. Her sister finds 3 coins on the sidewalk and gives them to Linda. How many coins does Linda have all together? So, how will we solve this problem? We know that the problem asks us to add. How do we know this? Yes, the clue word altogether tells us that. Remember that strategy from problem-solving strategy 1 in video 1? We could easily add the two numbers together, but we can also solve the problem by acting it out or modeling using real objects. I can use 10 coins to show how many coins are in Linda's wallet. Linda's sister gave her 3 coins that she found. So if we add them together, we have a total of 13 coins. We just solved this problem by acting it out. In other words, we modeled the solution using actual coins, just like acting out the real problem. Let's look at a problem where you can't represent the objects in the problem with real objects. I'll show you what I mean. Sandy owns 9 hats. Her sister owns double the amount of hats that Sandy owns. How many hats does Sandy's sister own? Depending on where you are when you solve this problem, you probably do not have many hats to use or act out this solution. Sometimes a problem gives you objects that are difficult to act out, like cars in a parking lot, or the many books in the library, or the hundreds of shoes in a shoe store. Does this mean that we cannot act out or model the problem? No. In fact, we can model the problem. What we can do is use tokens or other objects to represent the objects in the problem. In our problem, we may not have many hats, but we can use these tokens to represent or stand in the place of hats. Here is what I mean. If we make each token be a hat, how many tokens will we need to show how many hats Sandy owns? That's right, 9. 9 hats equals 9 tokens. Now, if Sandy's sister has double this, what does this mean? You're right again. It means 2 times this, or the same set added again, or twice. How many in all? That makes 18 tokens. But really, since they represent hats, that makes 18 hats that Sandy's sister owns. Wow, she sure owns a lot of hats. And there you have it. You learn to solve word problems by acting out the problems with the actual object, or modeling using tokens. Practice the strategy with our word problem games. When you get stuck, find objects or tokens and act out the problem. Thanks for watching, and always be clever.
Next, we have writing an equation. Solving life-freezing problems is often a matter of finding the right ingredients, setting up the math, and solving. An equation is math way of saying that two things are equal to each other, that is, they have the same value, are worth the same amount.
Write a number sentence or equation. You probably already know what number sentences are because you've used them. Do these look familiar? In this video, you'll learn how to use number sentences to solve a word problem. A number sentence is an equation made up of numbers. operation symbols like addition, subtraction, multiplication, or division, and an equality symbol. In order for this sentence to be true, what is on one side of the equality symbol should be equal to what is on the other side. For example, 4 plus 7 equals 11. This is a true number sentence because what is on one side of the equal sign is the same or equal to what is on the other side. Now let's look at how to use number sentences or equations to help you solve world problems. Mike has 6 marbles. Luke has 4. How many marbles do they have in all? Okay, so you know that we can act it all out, draw a picture, or use a number line to solve this problem. We can also skip those steps and write a number sentence or equation right away. We know that we will need to add because it says in all in our problem. That's great because you already know what operation symbol will be in our number sentences. What else do we know? We know that Mike has 6 marbles and Luke has 4, and we're trying to find out how many marbles they have in all. So we are adding Mike's 6 marbles to Luke's 4 marbles. Great! 6 plus 4. Now we add the equality symbol or equal sign, and we have the equation we are trying to solve. 6 plus 4 equals... What does 6 plus 4 equal? 10! You got it! Good job! Sometimes you will find that it is easier to first act it out, draw a picture, or use a number line before writing a number sentence. That's perfect! You can do both. But if you're ready to skip the first step, you can go straight to writing number sentences or equations when solving word problems. Use what works best for you. And there you have it, another problem-solving strategy under your belt.
Next is guess and check working. It is the simplest strategies. Anyone can give guess and answer. If they can also check that the guess fits the condition of their problem, then they have mastered guess and check. This is a strategy that would certainly work at the farmyard problem, but it could take a lot of time and a lot of computation.
Guess and check. In this video, you'll learn how to solve a math problem by guessing an answer and then checking that it makes sense in the problem. Did you know that experienced mathematicians often use the guess and check method to solving problems? That's because when 2 or more things in a problem are unknown, we have to try and try again to get proof that our answer is the right one. But be careful. Guesses should be educated guesses. In other words, they should make sense to the problem and shouldn't be wild guesses. Be sure to read the problem closely. Let's look at an example to understand how to guess and check. I am a 2-digit number. I have a 3 in the ones place. I am greater than 45, but less than 63. What number am I? We know right away that we have to guess the number to solve this problem. What else do we know? We know the final answer will be a 2-digit number. We also know for sure that there is a 3 in the ones place. Where is the ones place? You got it. We know the number will be greater than 45, or bigger than 45. So, would it make sense to put a big cow in the tens place? No. Why not? We're making a guess, aren't we? Ha! Of course, we can make guesses in math, but they can't be wild guesses. They have to make sense to the problem. In this case, we're looking for digits, not animals. Good catch. Okay, so can the digit in the tens place be a 4? No. You're right, that would make the number less than 45, wouldn't it? Good guessing and checking. Let's guess another digit. Could there be a 7 in the tens place? No again. That would make the number greater than 63. Remember that the problem says that the final number is greater than 45, but less than 63. Can you now make an educated guess to solve this problem? If you guessed 5 in the tens place, that makes the final answer 53. To know if we're right, let's read the whole problem again. I am a 2-digit number. Yes, we have 2 digits. I have a 3 in the ones place. Yes, we have a 3 in the ones place. I am greater than 45. Yes, 53 is greater than 45. But less than 63. Yes, 53 is indeed less than 63. We got it. We made some educated guesses and we solved this problem. Congratulations! You learned another trick to solving word problems. Sometimes you need to make smart or educated guesses, and then check your answers to see if it makes sense in the problem. Just remember that guesses have to make sense. They can't be wild guesses. Need more practice guessing and checking? You can find lots of word problems in our games. Have fun, and always be clever.
Next, we have working backwards. It is a standard strategy that only seems to have restricted use. However, it's a powerful tool when it can be used. It is frequently turns out to be worth looking at what happens at the end of a game and then work backward to the beginning in order to see what moves are best.
Work backwards. I bet adults often tell you to look ahead when you're walking or running, right? What if I tell you that you can look backwards for a few minutes right now? Well, I'm not recommending that you walk or run backwards, but solve a math problem by working it from the back end first. Don't believe me? Let's look at a word problem together. Paul has money in his piggy bank. His mom adds $5 to the bank. Paul takes out $2 to buy an ice cream, but adds $10 his grandmother gave him for his birthday. At the end of the day, Paul empties his piggy bank to count his money and finds he has a total of $20. How much money did Paul have in his piggy bank at the start of the day? This is a great problem because there are a lot of things happening. Money is being added and subtracted and taken out of Paul's piggy bank. What are we looking for? Right. How much money did Paul have in his piggy bank at the start of the day? Most math problems give you starting information and ask what you end with. But this one gives us what we end with and asks us to find out what we started with. So, the best way to solve this problem is to work backwards or work in reverse. First, using the amount that we have at the end of the problem to find out what we had originally at the beginning of the problem. We know that at the end of the day, Paul has $20. At one point, his grandmother gave him $10. Since we're working backwards, we'll do the opposite and take that $10 away from his $20 at the end of the day. So we will subtract $20 minus $10 equals $10. This is how much money Paul had before he took out money for ice cream. Paul took out $2 to buy ice cream, but that means he had $2 more than $10. Remember, we're thinking backwards. That's $10 plus $2 equals $12. Wait, there's one more step. Remember, Paul had $5 added by his mother in the beginning of the day. That means he had $5 less than $12. So $12 minus $5 equals $7. Guess what? That's our answer. Paul started with $7 in his piggy bank. It is always best to check your answer, especially when you've worked backwards to solve it. The best way to check is to now solve it by working forward. Let's do it quickly together. If Paul starts with $7 and his mom adds $5, that gives him $12. Check. He takes out $2 for ice cream. That means he then had $10. Check. He adds the $10 his grandmother gave him. That makes $20. Check. That's correct. Paul definitely had $7 when he started his day. Great job! The working backwards method doesn't work for every problem, but it does work when there are multiple steps to solving a problem. When you work through word problems on our online games and quizzes, see if you can find when to use the working backwards strategy. Have fun and always be clever.